In Lesson 12.2, we're considering operations with complex numbers. And the first one we want to look at is addition. So when I have two complex numbers written in a plus bi form, what I'd like to do is to add the real parts together and add the imaginary parts together. So as you notice here in this problem, we have two real parts, the 3 in the first one and 5 in the second. So we're going to add those two real parts together to give us a total of 8. And then in the imaginary parts of these two complex numbers, we have 2j and 7j. So we're adding those two together. That gives us 9j. So that's our final answer, 8 plus 9j. So just match up real parts and imaginary parts and add those together. We do basically the same thing for subtraction. We're going to work with the real parts and the imaginary parts. So here the real parts are 7 and 6. But remember now we're subtracting. So 7 subtract 6 is 1. So in our final answer, the real part is 1. And then we're going to subtract the imaginary parts. So for the imaginary parts, we have 9j minus, here again, remember the minus, negative 4j. So minus a negative 4 is like plus 4. So 9 plus 4 is 13. So we end up with 13j. To multiply two complex numbers, the first thing we've got to do is rewrite the expression in terms of j. So notice here with this example, we've got the square root of negative 4 and the square root of negative 9. So we want to rewrite that. We're going to take the square root of this negative 4, which is 2, and then an or j, excuse me. So I've got square root of negative 4. This part right here is the same thing. The square root of negative 4 is 2j, and then we've got it minus because that minus sign. So 6 minus 2j. Square root of negative 1 is j, and square root of 9 is 3, so that's 3j. So now we've got it in terms of complex numbers written in terms of j. So now what we want to do is, just like you would in any algebraic expression, you're going to distribute 3j times the 6 and 3j times the negative 2. So when we multiply those together, 3j times the 6, that gives us 18j. 3j times negative 2j is going to be a minus 6j squared. Skipping on down to this step. And I know j squared is the same thing as negative 1, right? So net minus 6 and negative 1 is plus 6. But we write our complex numbers in a plus bj form. So our final answer is going to be 6 plus 18j. Now, to divide with complex numbers, we've got to use something that's called a conjugate. And notice up here in this particular problem, 3 plus 4j is what we're given. Well, the conjugate of 3 plus 4j, is 3 minus 4j. Notice that this first complex number, we're taking the opposite here in the center, but we're not taking the opposite of the first term of the real part. Okay, so if it's 3 plus bj, then, or a plus bj, then the conjugate is going to be a minus bj. So what we do is multiply both the top and bottom by the conjugate. Okay, so we're going to be using that. So notice that's all I've done is rewrite that expression, multiply both of these by 3 minus 4j. Now, I know there's a lot of times here, but that's just showing you the multiplication that takes place. I would probably do this kind of like you do multiplying two binomials together. like first terms, 7 times 3 is 21. Outside terms, 7 times negative 4j is negative 28j. Inside terms, 2j times 3, and that's a negative, it's negative 6j. And then last terms, negative 2j and negative 4j multiplied together is 8j squared. So we're using the FOIL method to multiply these two together, just like we would with binomials. First, outside, inside, and last. And I do the same thing with the denominator, and we end up with this expression. Now we need to simplify some things. So what I want to do now is I want to go back and combine any like terms. And notice here, I've got these two like terms that we can put together. That gives us the negative 34j. And minus 12j plus 12j, notice what happens with that. That just drops out. So we no longer have a j in the expression for our denominator. The j squares, those are equal to negative 1. So I'm replacing this j squared with negative 1 and this j squared with negative 1. And then I just clean things up. So 21 minus 8, that gives us 13, bringing down the negative or minus 34j. And then look at our denominator. What happens with that? We have 9 plus 16 or 25. So writing the final answer, this is what the final answer looks like. Now, if I were writing this out, I'd probably leave it like this. But in answering some of your questions in my math lab, they may ask for exact answers in the form a plus bi or a plus bj. Get away from it. So if they ask for it in that form, that means you need to separate it. You need to write this as 13 over 25 minus the b here is the 34 over 25 times j. Or they may ask you just to write it as a decimal value. So you could plug in those numbers in your calculator. 13 over 25 is 0.52 and 34 over 25 is 1.36. Okay, but you want it to look like this. You want it to be in the complex number form.